An ellipse is basically similar or the same as an oval. So you guys are familiar with ovals. Ellipses have a few specific properties that make them very useful when we're drawing, specifically when we're drawing three-dimensional objects, especially ones that have a circular face. Before we get into that, though, we're going to discuss a little bit about the anatomy of an ellipse. An ellipse has two axes, and each axis is basically a line on which you can fold this ellipse over, and it will match up directly with the other side of it. So basically you can say that the axis cuts the ellipse into two symmetrical halves. And one of these is the major axis, and it cuts it across the widest span or dimension. Although, despite having a rather important sounding name, this is not a line that we will ever actually make use of. So don't worry about that. What is, however, important is the contradictory name of minor axis. And it's minor because it cuts across the narrower span of the ellipse. And we'll get into why that's important. Before we do, the actual width of this minor axis is referred to as the degree. It's the width of the entire ellipse. And this is specifically of the two widest points, if you can think about it that way, where you have one coming across this way and then the other this way. Of the narrower of the two, it's the width of that. And it's referred to as the degree. In order to understand any of that, you have to start thinking about why an ellipse can be useful in 3D space. Imagine that you have in your hands a coin. So let's say, it's got a little rim on it. There's some sort of person. So you've got your little coin. It's, whatever amount. And when you take this coin and you rotate it, so remember that a coin is a very small cylinder, so it's got two faces, but we're only thinking about the very, very flat circle that is on one side of this cylinder. And as you rotate your coin, it's going to gradually turn and turn and turn, and as it does, it's going to get skinnier and skinnier and skinnier until it is basically invisible. And you do, because it's a cylinder, you'll have this thickness here, but effectively it is narrowed down to a single line. Now we call the width of the ellipse that represents that circle in 3D space because here it's at full width of a full circle, and as we make it skinnier and skinnier, it's basically becoming just any other old ellipse with a variable width. We refer to that as the degree because it actually represents the degree to which this coin has been rotated in space. So you might be looking at a coin, let's say this is your head, and you've got your little coin here, or maybe it's a big coin. You're looking at it, when you see it as a full circle, what you see is this. But as this thing has rotated, now what you're seeing has a much smaller degree. So that's what you see. This has a degree of 90 degrees. It's actually measured in degrees, whereas this would be closer to something like 45 degrees. And it is actually the angle here between the face that you're looking at and the viewer, or rather the viewing angle. So here it's 90 degrees, and here it's 45. So it's basic geometry. The actual numbers don't really matter that much, but it's good to know the science behind it. And so eventually when it gets down to a skinny line, that's going to be 0 degrees because the face of this circle is going to be running parallel to the viewing angle. So it'll be like this. So that's one aspect of how this information can be used in 3D space. To reiterate, an ellipse will have a degree that is related to the angle of the actual circle you're trying to represent in 3D space relative to how the viewer is looking at it. And remember that anything that we draw is being drawn as though it's being seen by someone. So the viewer in this case is basically whoever is actually looking at the image. It's just it's capturing what this hypothetical viewer sees. Now, the other reason that the minor axis is important, and just to go over that again, your minor axis is this one, the line that goes across the skinnier side of the ellipse and cuts it into two symmetrical halves. The reason that's important is because if you were, again, to think about a circle in 3D space, remember that I'm actually saying in the 3D space pretty specifically, because a circle in 2D space is just a circle, but a circle in 3D space can be represented with an ellipse depending on how it's rotated. So the reason this minor axis is important is because in 3D space, you can have a line that runs perpendicular to the actual face of the ellipse, meaning that it's coming straight out of it. It's not coming out at any other angle, and it's not resting along the surface of the ellipse, but it's actually coming straight out. The minor axis allows you to find the specific line that comes out in that fashion. And I've actually got a pretty decent example of this in the written content for this lesson. So I'll bring it up instead of trying to redraw it. So as you can see here, the minor axis comes out this way. It comes off the surface and into space. And that's, while we're not really going to be worrying about that too much just yet, it's important to keep in mind, because if you have a cylinder, then the two ends of that cylinder are going to have their minor axes aligned to each other. So they will share the same line that represents their minor axis. Just as it does here. This line here, I'll highlight it in red, is the minor axis of both ellipses. And you can tell that this one here, if you folded it over this line, this two-dimensional line that is, that it would kind of lay right over this one. And the same goes for this. If you were to take this half and fold it over so it went directly over here, it would fall directly on top of it. Like I said, this is pretty complicated, and we're not going to be worrying about it very much right now. All I want you to remember and take away from this is the simple principles of an ellipse has a minor axis, which goes across the narrower dimension or span of the ellipse, and that the degree, the width of the ellipse, remember that term, the degree, corresponds to the width along that dimension. That's all you need to remember for now. We'll start thinking about the actual 3D implications more in the future, but for now, through the ellipse section of this lesson, you're just going to be drawing a bunch of ellipses. It's going to be a matter of learning to control how to draw these things. And in the exercises, you'll find me talking about things like drawing through ellipses, which means instead of trying to hit them in a single round where you can tell that this gets kind of uneven, that you want to draw it confidently and go over it one extra time before lifting your pen. This is because it keeps your ellipse even, and it gives you puts you in a better position to actually draw with the kind of confidence that you need to keep it even. Also, make sure that you're applying the ghosting method, which you should have already covered since you should be done the lines section and all of its homework. Apply the ghosting method to this as well. So don't just go in there, drawing your ellipses. Actually think about the angle that you want to approach the specific ellipse at, goes through the motion of it, and then execute it confidently. And it's okay if you've got a little bit of separation here, but that's something that you'll gradually work on to reduce it and tighten up that ellipse. So that's about it. I do apologize for the somewhat complicated, 3D talk. It is necessary to get it out there. Just don't stress about it too much. You don't necessarily need to have a strong understanding of it just yet. The coin analogy can be pretty handy though. It's rotating as you go, gets skinnier as the circle faces away from you. And the minor axis is literally just, if you were to take any flat object, like a Post-it note or a piece of paper or something, anything in 3D, any three-dimensional plane, will have three axes. That's one axis. Here's another. But then it has a third, which is perpendicular to these other two. And so the minor axis basically represents this line coming out of the surface for the circle in question. But again, you don't need to worry about that too much just yet. It'll come into play when we start thinking about cylinders. So that's about it for this video. As always, read the written content. The link will be in the description. The video can only go into so much, and as you can tell, I did kind of ramble about the minor axis and the degree a bit. So being able to step through the content at your own pace can definitely help you understand it and absorb it a little bit better. And it's got a few extra diagrams that should help. And of course, the homework for this particular part of lesson 1 is assigned there as well.